Hi everyone. We're going to start this session 2, and please come join. Where are you? Is Amit Naim? Amit Naim? Amit Naim, are you there? Andrew is, wait a minute, because it's Amit Naim is a duplication, his schedule at presentation. So maybe he trying to reach here soon. Yes, over the 5 minutes, and instead of you, instead of him, and you can present this first. Yeah.
So, do you want me to present now?
Wait a minute. 2 or 3 minutes, 2 minutes later.
No problem.
Yeah.
While we wait, thanks everyone for joining us at the second session of APRP. The first session had some absolutely excellent talks, and the presentation on quantum networking was most fascinating. While Jong-Hun's doing that, let me just share our agenda for this session. We'll be starting off with Amit Naim from HEC, and who'll be producing an introduction to PERN and the activities. Then I'll be giving you an Australian country update and some talks about what NCI future works are. Gulam will be presenting AI research activities of Sukhar IBA in Pakistan. Then Noor Ashila will be presenting the EBCK project in Malaysia. Asif Khan will be presenting on HPC and bioinformatics activities. And then Keon Kim will be talking about research platform and applying those ideas in the agriculture fields. So we're just waiting for our first speaker to join us.
Okay. Andrew, you should go first.
Okay, no problem. Hi everyone, I'm Andrew Howard, Associate Director Cloud Services and Innovation at the National Computational Infrastructure, which is located at the Australian National University. I'd like to present a couple of project updates of some of the activities that we're working on, and then primarily focus on the Data Mover Challenge. We're currently working on a hardware refresh for our Neuron Cloud. We're expecting to spend around $1 million Australian to implement more recent CPUs, additional memory, and add some more storage. We currently have about 6 petabytes of Ceph storage, and we'll be expanding that out to probably about 10 under the new infrastructure. We're also involved in a number of precision medicine initiatives. The first of all is the Prospect Project, which is connecting around 60,000 Australians who are suffering cancer with experimental therapies. To do that, we've implemented a program called VC Platforms, which is used for cohort selection. We've built on top of our Australian research environments, which is our graphical HPC front end, a restricted graphical environment based on Chasm. This prevents people from cutting and pasting from web services, and basically provides a controlled data portal. We're using Globus to transfer data from the 6 currently state-based sequencing facilities. And there's another program which we've just started called Guardians, which is to build out the national genomics infrastructure. We're still at an early stage of this using the GSI starter kit. We plan on implementing both Gen 3 and EGA in later stages of the process. The Genomic Data Infrastructure Starter Kit is available from the link below. I'd like to really spend most of this presentation talking about the Data Mover Challenge. As you've heard from the previous session, the high performance networks in our HPC facilities provide the key to data sharing amongst our research cohorts. We've got both FAIR and CARE-based data initiatives to make the data findable and accessible. NCI doesn't impose any ingress or egress data charges from our facility. And what we want to provide is friction-free data movement capabilities. We've found that researchers just want to access their data and don't have the time or interest to become network engineers. And we also want to have a rich range of tools and an ecosystem to transfer data between facilities. We're seeing a large increase in competitive science, which uses data obtained from satellites, telescopes, sensors, and the Internet of Things, ultra-high definition images, genome sequences, and external data sources around the world, combined for more effective research and data visualization. In the satellite space, we have input, which requires georectification, cloud removal, color and light adjustment. And we then add those into a data cube for longitudinal and transactional retrieval. So what we can do with that is basically draw a polygon over any area in Australia and zoom back over the last 20 years to look at the vegetation types and extent. Where that's really critical for us is Australia has a number of natural disasters every year. We have fires, floods, and droughts. So being able to look back over the data over time is really important. NCI, as a Tier 1 HPC facility, also have our cloud capabilities, which is called NIRN. We provide infrastructure as a service and platform as a service cloud capabilities on NIRN. It's also used to provide NCI's data portals, which are widely available to the rest of the community. It's also tightly integrated with our global storage, which is currently around 100 petabytes, and our NCI Guardi high-performance computing environment. It provides the foundation for our virtual laboratories and research environment services. I thought I should just zoom back a bit into the network space that we all work in. As you can see, Australia is well connected to the world with a number of paths. While we are remarkably geologically stable, we're surrounded by the Ring of Fire. That has the potential to cut a significant number of our fibres. So we're always working with our collaborative partners in APAN, on TN, and other network areas to provide reciprocal peering and backup capabilities. Where this is really critical for Australia is for the Sentinel program, which my team operate, which holds around 5 petabytes of data. And we are pulling between 30 and 50 terabytes of data per day down from Europe. We've needed to tune pretty much every element in that chain. And the Data Mover Challenge is kind of based around some of this work. So for those of you who are not aware where NCI is, we're located in Canberra. There's 2 Tier 1 facilities, NCI on the east coast of Australia, and our sister centre, Pawsey Supercomputer Centre, on the west coast over in Perth. The International Data Mover Challenge operates every 2 years, and the goal is to identify the best practice for systems, networks, and tools for large data transfers. We want to bring together experts from industry and academia to test their software and solutions for transferring huge amounts of research data. The challenge actually operates over our production, research, and education networks, and is really critical for Australian network capabilities. As one of the most distant network users and some of the largest network users in the region, we collaborate with international research and education community and our data suppliers like the European Space Agency to tune for timely delivery of products to NCI. We've been running the Data Mover Challenge on a 2-yearly basis. Our first one was in 2021, where we connected sites in Australia, in the US, across Asia and across Europe, and also provided a link through Saudi Arabia. In the last iteration of the Data Mover Challenge, we were able to expand our network to cover every continent except Antarctica. And we were pleased to welcome RNP in Brazil to participate. The Data Mover Challenge is operated by our research and education networks. There's many of the people in this room who are providing resources and capabilities into the Data Mover Challenge. But if you're interested in participating in the Data Mover Challenge, either by entering a product or a service, or providing access to one of your data transfer nodes and some technical expertise, we would certainly welcome any and all participation in the activity. We're also hoping to be able to expand to Antarctica in the next iteration, using the Starlink facility that is at the Australian base. So our DMC23 network covered 5 continents. And as I said, we welcome South America, modelling 2 data transfer scenarios, over 100 gig research and education production networks, and also over Starlink for field-based data acquisition. And our Australian Antarctic division has now installed Starlink at the South Pole, which supports our base. One of our researchers actually smuggled 8 dishes down there and bonded them together. And for the first time ever, people are able to video conference in real time, watch Netflix, and really communicate with the outside world in ways that were never possible before. I'd like to thank all of our DMC23 network partners. Once again, they've been mentioned in previous slides. We all work together collaboratively to build the experience and skills of our current generation of network researchers and engineers, but more importantly, to build up the networks between the up-and-coming network engineers. Something that's absolutely invaluable in our APAN community is that we're able to respond remarkably quickly to network issues. However, what we're starting to see is a lot of the network engineers are getting grey beards these days. So we're looking to pass the baton on to the next generation of network engineers. I'd also like to thank our data transfer node partners, once again from around the world, and in particular, ISTI and our KDDI partners. So as we've heard, there are challenges for large data transfer over global RNA networks. They cover the areas of disk management, so the management of files for efficient transfers, access management integration with federated services in a single login, protocol adaptability, operating system tuning, CPU I/O network latency, the lots of small files, the metadata operations issue, parallelism, keeping the network full, and dynamically adjusting based on network conditions. The judging panel is made up from a number of people around the world: Professor Francis Lee from Singapore, Professor Paulo Grasso from the University of Amsterdam, Hirotaka Sato from APAN58 and KDDI, Akira Sang from APAN58 and KDDI, Marcos Felipe Swartz from RRP in Brazil, Tim Chone from JISC in the UK, and I have the honour of being the Chief Judge, and I'm from NCI in Australia. Our Data Mover Challenge teams, we had 6 teams participating. I'll briefly go over their approaches. Each of them brought a unique and innovative way to deal with the transfer. So Team Falcon from the University of Reno, Nevada, was inspired by hands-on experience, understanding that understanding the data provides insight into the best methods of data transfer. So they used a heuristic feedback between sender and receiver agents, which was dynamic for I/O optimization and network parameter adjustment. Team Saito were looking at DTN optimization using dynamic network estimation and DTN impedance matching. They used the Sienna environment for network innovation, networks and test beds. Their approach was to use automation and AI to optimize transfers, looking at the homogeneity of DTN deployments, modification of the switch buffer sizes, host buffer sizes, etc., looking at the timely delivery by adaptively rate limiting or flow controlling during transfer, and adapt to non-deterministic network conditions. They provided a DTN as a service capability laid on Jupyter notebooks. Team Livewire from Australia used their MediaFlux product, and MediaFlux is a data management system which is used by NCI. They were able to use MediaFlux to drive automated replication, deduplication, and distribution across the Data Mover Challenge network. They used 10 parallel streams and provided a visualization of data transfer flows for rapid performance indication, and used a virtualized storage layer for optimizing I/O handling and metadata management. Team Mushishino from the University of Tokyo in Japan demonstrated a high performance and flexible protocol based on APRP, which is a protocol designed well to work in impaired network conditions. It was primarily developed for managing network disasters in Japan, where the network services can change dynamically. It uses UDP for long fat networks with packet losses, provides a socket-based library implementation, which emulates a lot of the TCP library, has a number of modes, fair, modest, aggressive, and more, and performed extremely well after over Starlink. So this was after a week of torrential rain in Japan. They got remarkably good performance numbers. One of the most interesting ones from the judge's point of view was Just SSH, a PhD student. Basically was just a client-side modification of SCP, the traditional file copy encrypted copy program. He used multiple streams of SFTP supported over SCP, and immediately was able to achieve a 10 times performance improvement over standard SCP. If anyone is interested, the GitHub link is there. The judges were all compiling and building this during the demonstration, and the results are really, really great with a single letter change on an existing pipeline. Team Racing and Robust HPC Alliance, a commercial company operating out of Malaysia and China. They used a UDP-based protocol with adaptive tuning. It excels integrated network conditions, adapts to firewalls, handles compression, and is effective for high throughput transfers from the field. And they provide a complete end-to-end data management platform. Their main focus is on video work, so being able to transfer video in a high-performance way for collaborative editing with teams shooting in the field. So that brings me to the end of my presentation. We're running a little short of time, so perhaps if anyone has questions, could they either send me an email or drop them in the chat. So thank you very much, and I'll hand back to Jong-hoon.
Yeah.
Has our next speaker arrived?
Yes, the next speaker is Amit Rahim, and go ahead on the table. And anybody question for this Andrew Howard, the NCI? Wait a minute. I have one question. Is you mentioned about this cloud and the HPC's combination, the models. Is when you the HPC and the combination with this cloud system, is there any obstacle you have?
So we use what's called Open On Demand, which is produced by Ohio State University. That gives us a graphical front end to the services we're offering both on HPC and on the cloud. So we present, users don't need to install any tools or applications to come on board on NCI. They're able to use a simple web-based interface, and we've populated that interface with a variety of common toolkits. This allows users to scale from cloud-based systems all the way up to the highest performance HPC nodes that we have. They just drag down a box and basically select how much resources they want to commit to a project.
Okay, thank you. Thank you. And please give again these claps to him. Okay.
So our
Yeah.
next speaker is Naam, who'll be giving us an introduction to PERN and a project update. Over to you, Naam.
Thank you very much. Can you change this? Oh, great. Good morning, everyone. Can you please give the email address? They want to NCI, the same email address, the contact details.
Andrew.howard@anu.edu.
Can you share the your slide, last slide? They want to
Yep.
take some pictures of that.
Okay, just a moment. Everyone got the details?
Okay, please change this. Thank you. Good morning, everyone. Thank you, Dr. Moon, for coming here in Pakistan in APAN58. So I will be presenting the PERN and the updates what we are doing in the PERN. So let's start with the infrastructure what we have actually. A powerful domestic network we have deployed throughout the Pakistan, and lot of universities and colleges which we have connected. So basically we have actually 301 institutions connected in 48 cities. So Pakistan is geographically distributed in the 5 provinces. So we have 301 institutes which is connected, in which if we can segregate, that is 179 is the main universities, 72 is the sub-campuses, and 50 colleges, the degree awarding colleges, which we are connecting over the PERN. So we have totally 35 gigs of internet bandwidth, which we are distributing across all the HEIs and institutions. We have divided, if we see in the map, that we have divided our we have created some of the point of presence, we call it POPs, there are 23 POPs, aggregated POPs, some of the aggregated POPs in different cities. So from these POPs, we are actually connecting our universities, the nearest universities from these POPs. So a part of that, we have one IPLC link, which is directly connected to the NRENs. So we are utilizing this for the many of the research and education activities. So in what we are doing is right now in 2024, we are upgrading all of our core infrastructure from 10 gigs to 40 gigs. And we are also managing our footprints to more 68 cities. So we are going to the rural areas as well. So we are planning actually in 2024 to actually increase our capacity as well as to take on board more universities from the rural areas as well. So it's this overview. All of our universities are IPv6 enabled, and sorry, yes. So dual stack is configured. Multi-homing means that we are not taking the single source of internet. So we have dual homing. We have getting the services from 2 different providers in order to redundant our internet traffic. And we have the DWDM network, more than 8,000 kilometers of fiber. We have dedicated fiber, leased that, providing ANICA services. So basically, we are providing 3 services. If we see that we have 3 pipes. One pipe is for the general internet traffic. Other pipe is for the NRENs, which is the research and education link, in which we are doing our research, which is TEAN3 network. And the final is the intranet. Intranet is basically the pipe in which we do video conferencing. We do actually the private cloud data, and IP phone services, which we are running within the Pakistan. So this pipe is utilized from the intranet pipe. So PAN has its own DWDM network. So what we call is that the 8,000 plus kilometers of fiber, which is in the ring format. We have created 3 rings, and all the rings are interconnected to avoid any congestion, to avoid any fiber breakage. So to redundant, we have created the rings, and all the rings are now enabled on the 40 gigs. If we talk about the services, what services we are giving to the HEIs, like we are giving the internet, some of the value-added services like smart and safe universities services, in which we are providing the blanket Wi-Fi coverage. We are giving them the video surveillances. We are giving them the DNS services, e-learning platform, the cloud services, which we are now going to implement in this year. Video conferencing services, anti-plagiarism software through Turnitin, and trainings. These all are the value-added services. And we have agreement with the Microsoft in which we are giving the license to all the faculty and students. They are utilizing that as well. So this is our project. We call it the Smart and Safe University project, in which we provide the blanket Wi-Fi coverage to each university. So we have over 36,000 plus students, concurrent students connected to this networks, and this is we says that is a centralized Wi-Fi network, and we are connecting through our eDORM services, and everything is centralized. So this is a very huge project in which we have deployed more than 8,000 access points throughout the Pakistan. So a part of that access points, we have deployed more than 7,000 cameras in order to monitor the things of the universities. One of our main project in PAN is the IXP. PAN is hosting Pakistan one and only exchange point on 2 geographical locations, I said, in 2 cities. So basically all the carriers which we have connected on that access point, exchange point. So this is a very huge project, and PAN is a part of that. So we are hosting that exchange point. Let me discuss what we are doing in future, or what we are doing. A part of the PAN is that World Bank has invested actually $400 million in education sector through Government of Pakistan, out of which 120 million is for the R&D grants. So PAN was actually allocated 50 million under that program to actually connect colleges. So we have connected the universities, we have connected the sub-campus. Now it's the mandate is to connect the colleges as well. So under this project, we have to connect at least 135 colleges countrywide, and we have to upgrade the backbone. We have already upgraded the backbone from 10 gigs to 40 gigs. And then when the links will be deployed, eDORM services will also be extended to all these colleges. A part of that, a big project is the cybersecurity project. So we are developing our own CERT, educational CERT. Government has already given us the mandate to create the CERT, in which we can actually implement the security operations center, a centralized security operations center, which will be in which we will be creating all the incident and response mechanism. If any universities get any attack, they will tell us, and we will be helping them out. Internationally, we will be collaborating. We will be getting the licenses from the AP CERT, which is the Asia CERT, and the FAST, which is also a worldwide CERT. So we also a part of smart colleges. We have actually implementing the smart classroom, which is actually the funding of Chinese government. I'm telling you the later. So The one good project which is related to this is the high performance computing. High performance computing, in which we are actually, it would be the state of the art supercomputing facility which we are creating in Higher Education Commission in PERN, in which the university will take advantage. They will not use the external services, rather than we as a PERN will provide them the services to use the HPC services. And it would be the first deployment in the Pakistan. It is on the water cooled technology. So we have done the RFP of that project, and this is actually more than $4 million of the total budgets. So I was telling about the grant which we have got from the Chinese government, in which we have actually developed 50 smart classrooms. All the universities, major universities, has been equipped with the latest smart classroom technology, in which actually the idea is to make two classrooms. One is in main university campus, and one in the rural area. So the same level of education we get in what we get in the metro cities. The same level of education one professor which is teaching in the metro city, the other rural area will also get the same environment. So the idea is to give the extended version of a classroom from a metro city to a rural city. So in which we have deployed 3,000 VDIs for the students. Like we are sitting here, and every student has their own VDI to actually do the labs as well as to attend the lectures. So I was telling about the cybersecurity program. This is our roadmap to cybersecurity. So in this year, we are focusing on two major projects. One is to develop a cybersecurity program, and one is to actually develop the high performance computing facility in PAN. So both projects has been executed, and it's on the implementation basis. So in our cybersecurity program, so this is our roadmap, is to create offensive security, in which we give the vulnerability assessment services and penetration services to the HEIs. Then defensive services, which we will provide the antiviruses, EDRs, SIEM technology to the HEIs. And last but not the least is to train the people, because in security, training is very much important. The user-based training, and on technical and non-technical board training, we are planning to give to the HEIs. Last part is to, once everything is in place, then we will be creating the CERT, educational CERT, and it will be linked to the other international CERTs. Thank you very much. Any question and answers, please?
Thank you, Naeem, for the presentation. I just have one question related to the HPC project. So you mentioned about the HPC project. So, yeah. I mean, has it been executed or not yet? And if it will, then can you please tell some detail about it? I mean, how many nodes are there? How many GPUs are there? What type of GPUs are there or not? Okay. So thank you.
Can you give me the presentation back, please? So actually, everything is right here, and your answer is there. So basically, we are creating a cluster of HPC. The cluster which would be deployed in one of our data centers, we have actually implemented, established the state-of-the-art data center, which would be in Karachi one, and other is in Lahore. So we are actually building this facility, which actually this is a special facility. The servers, the compute which we are using, and it is a water-cooled server. So we are developing that facility in order to take maximum benefit from in terms of utilization perspective. So there are 24 computing nodes in this cluster, in which to our login nodes, to our management nodes, and 8 are GPU nodes. So this is connected all with the infinity band switches, and to facilitate further, we are giving 3.5 petabits of storage. We will be actually sharing this storage with our HEIs. If you calculate this, if I'm not wrong, it would be around 170 plus of teraflops in GPU mode, in the CPU mode, and more than 2000 teraflops which in the GPU mode. So we are using H100 GPU, which is actually in which we can segregate virtually the GPU to the researchers. So we are using the latest GPU in this project. So I hope it's.
Okay, anybody question about that? Okay.
Thank you very much for briefing about this overall project. Well, I have a question that actually I belong to a new university, that is University of Lahore, pretty young, about 1 year old, but we are away from these services. So how can we connect with you, and what should we do? Just guide me simply that how to proceed with you.
Thank you very much. First, you need to be a part of the PAN. In order to, I will share you the contact details. So your university can contact us, and we will enable you on the PAN. Once you are in the PAN, then you will get all these services. There's no issue.
Okay. Oh, yes, one more.
Hello, can you share the timelines of the educational cert?
Yes. Right now, actually, this project is in the award phase. So we have done the tendering in way back in the March. Now everything is finalized. So it is in the awarding phase. So when it is award, within a month or so, we would be starting the implementation. So by the mid of November, I think it would be start functioning.
Okay, we go to the next starter. Yes, Andrew.
Thanks, heaps, Naeem. That was a really fascinating presentation.
Thank you very much.
Next speaker is Ghulam Majtaba from SICA IBA. They'll be presenting on AI research activities at SICA IBA University in Pakistan.
Thank you so much. A very good morning to all of you. Thank you so much, Prof. Moon, for inviting me for ARPR session here today at APAN58. I am Dr. Ghulam Mushtaba, and I am from SICA IBA University. So the topic of my presentation is AI research activities at SICA IBA University, Sakkar, Pakistan. So this is the brief agenda of my talk. First of all, because maybe this university is new for some of you, so I quickly will talk about IB University in a minute or two. Then we established a lab called CRAB Lab, so I'll quickly discuss what is CRAB Lab at SICA IB University. Then I'll explain some of the AI projects which we do at IBA Sakkar University, and some of the computational resources which we have to run the AI projects, to train the AI models, and to test the AI models. And I'll discuss where we deploy those AI models to run the applications in real time. And I'll also discuss some of the challenges we face in terms of computational resources and some future requirements related to the computational resources in particularly. So SICA IB University was established in 1994. It's a public sector university in Interior Sindh. So in total, there are 4 different faculties at SICA IB University: Faculty of Science and IT, Faculty of Management Science, Faculty of Engineering, and Faculty of Education. So I belong to the Faculty of Science and Technology. So Faculty of Science and Technology has a department called Department of Computer Science, where we offer these 7 different programs: BScs, BScs with a specialization in AI, Software Engineering, MScs, MSCI, MSSC, and PhD Computer Science. So at Department of Computer Science, we have state-of-the-art classrooms and laboratories, such as Center of Excellence for Robotics, AI, and Blockchain. We call it a CRAB Lab. So besides the CRAB Lab, we have other different labs like Software Engineering Lab, Data Science Lab, System Engineering Lab, 3D animation and gaming lab. So I lead a lab called CRAB Lab, which is the acronym for Center of Excellence for Robotics, AI, and Blockchain. So at CRAB Lab, we have 3 different clusters. One is called the robotic clusters, then we have AI cluster, then we have blockchain cluster. Every cluster has a different team working under each cluster. Each cluster is led by a team lead. So this is the image of the CRAB Lab. We established this CRAB Lab with the help of Government of Sindh back in 2019. So overall, 154 million were awarded by Government of Sindh to establish this lab. So we have state-of-the-art infrastructure at CRAB Lab. So these are some of the platforms, robotic platforms and AI platforms, which we use frequently at CRAB Lab. So some of the platforms include Miro Robot, Pepper Robot, Now Robot, Checkal Robot, Ozo Bot, and some other, infrastructure. So we have also the state-of-the-art GPU-based machines where our students run the AI tasks to train their model and to test their models. So these GPU machines has normally dual GPU of NVIDIA series 2080. We have also multi-core processors in it. We have around 64 GB RAM in each PC. And we have SSD and SATA storage there in GPU. So we run several activities at CRAB Lab. So these are some of the images where the students are showing their semester project of AI and robotics. So, well, this was the introduction, brief introduction of Sakyarayabhi University and CRAB Lab. So I'll talk now on a few AI projects which we run at CRAB Lab or which we have developed in past and which we are currently doing at CRAB Lab. So this is our first project, which is called the CallSense. CallSense is an intelligent application which we develop for call centers to analyze the calls and batch inference, offline batch inference time. This project we did with the collaboration of Cybrid. Cybrid is our industrial partner in this project, and it's running a lot of call centers across the Pakistan. And Cybrid also provided us the data set to train our model for analyzing the calls. By analyzing the calls, we mean we need to identify the sentiments of the calls, and we need to elicit the aspect from the call. So, we receive so many calls in the call centers. At the end of the day, our call center company just tell us, okay, this number of calls you have received this month. But through CallSense, you can tell them more about the calls, like, okay, we receive, for example, 5,000 calls from your side, and out of 5,000, maybe, for example, 4,000 were in a positive mood or happy mood, where the customers and agent talked in a happy mood, and 1,000 maybe are in a angry mood. And if in angry mood, so what are the aspects behind the angriness? I mean, whether the customers were unhappy because of the services or quality of the food, maybe anything. So this application is deployed at real time. So this is the website where you can find callsense.ai. So this is deployed on AWS server. So if you know more about this CallSense, so we have this link on YouTube. So YouTube contains a detailed video on the CallSense. So this is the landing page of the callsense.ai. So and also the landing page contains a video which guide you how to use and how to register on CallSense. So this is the methodology we use. So we use, if you can see, we use the dataset taken from the Cybrid, and we use deep learning and LLM-based algorithms to find the emotions and aspects from the calls. So this is the overall, as I mentioned, this is end-to-end application which is deployed at real time on CallSense. Our call centers can also register. Under call centers, many companies can register. Under companies, we can register several agents. The agents can, analyze the calls of a particular company and share the reports to their managers. So this is some of the, results or report for the calls. So you can see there are 4 calls which are transcribed automatically, and the system also elicit the aspect, what topic is there in the call, and the topic, the customer and agent is talking positively or negatively about that particular aspect. So through CallSense, you're not supposed to listen the call. The system will automatically take your calls and analyze automatically using the autoencoders and LLMs. So this, We publish our research in two impact factor journals. So these are two journals where we publish the findings of the call sense. So this overall project was funded by the NRPU HEC scheme. So this is another project. This is a Canadian-based project. So we took it from the Upwork. So this is called Storied Life. So this project we hunt from the Upwork. So in this project, our client needed an application where the old people can talk to the application. This is purely voice-based application, where the old people can talk to this application about their life experiences based on some predefined chapters. So you can see these are predefined chapters. So the user can choose any chapter, and this sweet lady can talk to him or her on a particular chapter, and will start conversation with the user. And eventually it will make the chapter summary. And for example, if I'm a user, if I'm choosing 10 chapters, so it will talk to me on those 10 chapters, and in the end, the system will automatically generate a biography book on me on those 10 chapters. So this is first part. Recently this project, Rafe Moshe is a client for whom we are developing this project. He recently raised $2 million funding from Canada to complete this project. And in second part, from the biography book, we are aiming to generate the animated movie from the Storied Life. So this is another project we did on fake reviews detection. I mean, these days e-commerce platforms are very common. Most of the time we buy things from online platforms, but the issue, I mean, normally we buy it by looking at the reviews on the e-commerce platforms, but there's one issue of fake review on particular product, right? So many, sellers hire the agents to provide the fake reviews on a particular product. So in this project, we tried to detect the fake reviews from e-commerce platforms, especially the RAS.pk. And we tried different features, like we tried the textual features, we tried the lingual features, and we tried the user behavioral features to identify the fake reviews. And we found that as far as the features are concerned, lingual features and textual features are not suitable to detect the fake reviews. Rather, I mean, the behavioral features are very, very important to detect the fake reviews. By behavioral features means at what time the reviewer logs in to the system and put the reviews, and what is the frequency of those reviews from a particular user. So this will help you to find the fake reviews. So these are some of the results. So we achieved around 81% accuracy F score by using the gradient boosting algorithms and user-defined features, user behavioral features, sorry. So we publish, this paper is recently accepted in a paper, SCM transactions on Asian and low resources language information processing. By the way, this system can work with the English reviews as well as the Roman Urdu reviews. So this is the third project. Again, it's on hate speech detection. So in this project, we actually produce our own data set to find the hate speech reviews from Twitter tweets. And in this database data set, we have English reviews, we have Urdu reviews, and we have the Sindhi tweets also to detect the hate speech from these three different languages. So it is a multilingual hate speech model. So we also exploit the use of explainable AI to interpret the results of the, our classification results. So this is the overall methodology. You can see we form our data set and we employed several feature engineering technique. And here we employed the latest models like transformer models to classify the hate speech tweet. So initially we classify the tweet into two categories, whether the tweet is hate related tweet or non-hate related tweet. If it is hate related tweet, then further it classify the hate tweet is related to disability of the people. It's talking about the gender, it's talking about the nationality or ethnicity or the religion. Okay, so you can see we employed the several state-of-the-art model like Robota. So we found that distilled Robota is very much efficient to find the hate speech. These are some of the results of XAI. So you can see we have tweet in English, and the overall prediction for the hate speech is 63% and 37% for the non-hate tweet. And it's showing all the features based on which it classified the tweet into the hate speech tweet. So this is another example of the Urdu tweet. And we have also given one example for the fine-grained level, like it is head to it, but on what type of head to it, disability or others, right? So this is another project. So a novel deep learning-based computer vision-based intelligent application for post-flood disaster management. So here we use aerial images to detect whether the area is flooded or not. If it is flooded, then what objects are there under the flood? So we again employed the computer vision-based algorithms to detect the areas. So these are some of the images of semantic segmentation where we classify the image as a flooded or not flooded. And through the help of semantic segmentation, we detect the objects and classify the objects in a particular category. So these were some of the projects which there are a lot of projects, but because we just have 15 minutes to finish this presentation. So now I'm talking about the computational requirements we have at our Crab Lab to do these AI projects. So first of all, at initial level, we have these machines, GPU-based machines, where our students can, or our scholars can run the AI projects to train the AI models and to test the AI models. But of course, these are not fair enough to run the complex AI tasks on these machines. So because we have a limited VRAMs, we have a limited RAM, we have a limited computational power in these machines. So we have two alternatives. Either we use Colab, or we have a strong collaboration with the NTNU. So under two different projects, we have a NORPART connection project with NTNU Norway, and we have another project called RAPID under Erasmus+. So normally, NTNU provides the access to our students which are on the exchange program, or faculty which are on the exchange program. So we also use the HPC established by NTNU. So this is these are some of the images of HPC established at NTNU. They call it Ethune. So overall, there are 188 nodes. They have around 8,580 CPU cores. They provide the storage of 550 TB. Overall, they have 234 GPUs, as mentioned by the Naeem. In HEC PAN project, they are deploying HPC where they have 8. If I'm not wrong, 8 GPUs having H100 series. So at NTNU, they have all the series GPUs available, starting from P100 to V100 to A100 and H100. So about H100, they have overall 56 GPUs available. So these are all the 188 nodes. So if you can see, there are some nodes which are only CPU-based nodes, where we run the less computational power AI projects, and there are some nodes which have some GPU available, so where we can run the advanced AI complex task. But for deployment, as I mentioned, for deployment, we normally use the cloud provider option. So mostly we use AWS servers, where for storage purpose, we use S3 bucket of AWS and AWS Lambda. For future, as mentioned, at IBA Sakkar, we have limited computational power. So at IBA, we are aiming to establish a regional consortium of regional universities to form the HPC cluster, where we can collaborate to one another and run the AI tasks. So at Sakkar IBA, as overall in Sindh, we have 5 different campuses of Sakkar IBA University located throughout the rural Sindh. And we have also some other universities like Arod University, BNB University, Shah Latif University, Mehran University campus, and some other. So we can form a consortium to develop this HPC. So we are aiming for it. So hopefully in near future, we can come up with this project. Thank you so much. If you have any question to ask.
Anybody question? I have a question.
Sure.
And your achievement for the AI area is very great.
Thank you so much.
I'm surprised, even though you have a very weak computing environment. Do you have any plan to just get more the CPU, GPU, or the HPC, or the computing resource? Do you have any plan?
Yes, as I mentioned, so we are planning for HPC cluster. So by forming a consortium of different universities. So right now we are using the Google Cloud, Colab for running the AI tasks. But presently, we don't have any other option other than the Ethune and Colab. Yeah, but in near future, we are aiming to form a consortium of different universities, but specifically available in the rural Sindh. like Naeem mentioned, they are, I mean, forming a cluster having the nodes in, Lahore, Karachi, and Islamabad probably. But I think we want to cover the area from Rahim Yar Khan to probably Hyderabad. So it's a rural area of Sindh and Punjab, so where we can provide these HPC services.
Okay, thank you.
Thank you.
Yes, go ahead next, Andrew.
Thank
Okay,
you.
our next speaker is Noor Asila from Malaysia, from UPM, who'll be talking about the EBCK project in Malaysia.
Okay, thank you, Andrew. Let me share my screen. I cannot, okay. So can everyone see my screen?
Looking good.
Yeah, okay, thank you, Andrew. Okay, so I believe it's almost afternoon there. Good afternoon, everyone. My name is Noor Asila. I am from University Putra, Malaysia. Good to see everyone. Some of them are like twice a year. Okay, so today I'm going to sharing what we have done to extend one of the project related to this APRP work group, which is we applying the extra budgetary contributions from Korea, the EBCK 2024. So we propose a project titled Asia Pacific Research Platform for Distributed HPC Application for the EBCK 2024 grant, which the closing date is in our university, the closing date is end of July. So basically this project is to expand the previous project name that mentioned by Moon in this morning, which is the Building a High Bandwidth Distributed HPC, which was promoted last year. And what we're going to do for this project is focuses on enhancing the Asia Pacific Research Platform, the APRP.KR. So this platform is managing the CPU, GPU computing resources using the container cloud technology. The APRP.KR is basically provide an easy to use interface, very user friendly. So our researchers in our university really like the platform. And it is very suitable for the non-computer science background. So the previous project, which is the Building a High Bandwidth Distributed HPC, is funded by the ASICONEC and the TNCC, an international collaboration project. This is an international collaboration project which initiative involved from the Korean, Australia, Malaysia, and Pakistan. Basically propose the high bandwidth HPC infrastructure to share data and computing resources through the TN and NRAN for the benefit of Asian countries. So this high bandwidth distributed is basically has three main activities. First is building a big data superhighway based on TN. Secondly, developing a distributed HPC platform, which is the APRP.KR. And third is presenting the pilot use case in AI and bioscience. And the goal of this big data highway system among participating countries and create a high bandwidth distributed HPC system to address the lack IT infrastructure, especially in Malaysia. So the initial phase for the high bandwidth project is verified the feasibility of the platform, and now the second phase is actually to seek to enhance the GPU and CPU resource utilization. So currently the status of the APRP.KR, the platform that developed from the high bandwidth distributed HPC application, is having not really being fully utilized the available CPU and GPU resources. So this is actually the challenges that we like to resolve. So once it can be resolved, it may enhance the system performance and usability. So the objective of this project basically to enhance the APRP.KR platform so that it can be effectively utilized by university researchers, students, and members of APRP countries by providing a new value and benefits in the field of high performance computing. So the purpose of the project clearly is to enhance the APRP in order to fully utilize the CPU and GPU resources, and also to provide this service to all the researchers. And by this enhancement will enable this user to leverage advanced computing capabilities for their research and academic pursuit. Okay, so what is the expectations? Of course, the expectation is to get the fully the full utilizations and improved performance from the CPU and GPU that available in the resources, I mean in the server that provided for this whole project. So this project, if managed to be resolved, will enhance usability with a more intuitive interface for researchers, students, and APRP members, expand computational capacity to support diverse applications, and provide update documentation and training materials. So additionally, successful pilot use case in AI and bioscience will demonstrate the platform to enhance capabilities and potential. So this is what among our plan to to approve the success of this project if we manage to get the grant. So members of the project, so I'm going to be the Malaysia PI, and Moon going to be the chief expert from Korea, Hyun Kim from the expert from Korea, and some other members from Malaysia, which who are the Adwati Sali and Katirasan. So the budget and duration, so the budget that we requested, the maximum is actually 60,000 USD, and we expected that we will complete this project around 18 months. So this is the project implementation plan. So if we manage to get it, so we plan to start in January 2025, and we should complete everything in June 2026. Okay, so basically that's all from me. So yeah.
Okay. Anybody question about that? Okay, now I have a question. There's Asila.
Yeah.
There's are you already submit your proposal?
Yes.
When is the result? When?
So we already submit the proposal. So the closing date is actually in end of July. But so we submit to our ministry. So what we I've got last week I called them, and then they said that it's still in the ministry, and they will forward it to the to the Korean to the Korean person in charge. So from my part, it's actually already done.
Okay, and I want the other question is if not we get the CARE grant the proposal, and we have we need to the second the plan for the support is this
Yes.
the platform.
Yeah, I think the backup plan is probably I'm going to find some grant from Malaysia, and I don't know if it's okay. There are several grants offered by the ISPF. I mean, that is from the it's not European, from the UK grant. But maybe to be safe, I will try to apply grant from the Malaysian Malaysian Open Grant.
Okay, and I also still looking forward to the other funding source in the Asia and the Europe, in Korea. So the weekend find there's a new funding source to make upgrade those the research platforms. Okay.
Okay.
Let's
yeah.
have a try.
That's
Yeah.
good.
Thank you for your the presentation. Okay.
Okay. Welcome.
Yep. Go ahead, Andrew.
Thanks, Asila. Very great presentation. Thank you very much.
Thank you. Thank you, Andrew.
Our next presenter is Asif Khan, one of our long-term collaborators, who'll be talking about HPC and bioinformatics activities at Perdana University in Malaysia. Over to you, Asif.
I sent a notice to him before the 5 minutes, and he not catch up that. So the next speaker is Kim Reddy.
Let's move on to Keon and come back to Asif once he comes online.
Okay.
So our next presenter is Keon Kim from KISTI in Korea, who will be presenting another presentation on research platform and how it applies for the agricultural fields. Over to you, Keon.
Can you hear my voice?
Good. Excellent.
Yeah. Can you see my presentation?
All good.
Good.
Okay. Thank you. Hello, everyone. My name is Kyung Kim. I'm working at KISTI. KISTI is developing a big data management platform based on a container environment called Korea Research Platform. We are currently applying the big data management platform to the agriculture research field and are conducting an agricultural big data research platform development project. Today, I will explain this project in detail. I will explain in the following order. Recently, rural areas in Korea are experiencing problems such as regional extinction due to aging and population decline, low agricultural income, climate crisis, and environmental destruction. As various problems like these are occurring in rural areas, the need for a big data management platform for smart farms is emerging. In addition, there is a gap of about 2 years in smart farm technology in Korea compared to advanced countries. In addition, in order to settle into the second generation smart farm that can realize precision agriculture, data analysis and utilization, and cloud-based platforms are essential. For this reason, Seoul National University and KIST and the Rural Development Administration are carrying out a project to develop a cloud-based big data management platform. I will introduce and explain the goals of the project currently in progress. The project name is Development of an Integrated System for Application for Agricultural Big Data and Models. The project will start in April 2022 and run for 3 years. The total amount is approximately $677,000. The main organization is Seoul National University, and KIST is participating as a joint research organization. The goal of this project is to develop a platform that provides API services for third-party developers to deliver information to end users based on agriculture models and data containers. This system uses the term model API, which is developed to convert each agriculture crop model into an API so that machine learning performance result can be obtained simply by executing the API. You can easily understand it by watching the demo presentation. We are already in the third year. In the first year, we completed the infrastructure configuration and development using open source to develop the back-end system. In the second year, we configured the login system for user management and performed work to link model APIs developed by Seoul National University and developed an interface for users and administrators. In the third year, we are conducting tests based on actual users and are working on transforming the platform to the Rural Development Administration system. Let me explain the overall configuration of the system with explain in the white box. The explain in the white box is a machine learning example that predicts the amount of water according to irrigation conditions. In fact, if you look at the example in the white box, you can perform the following steps based on the results using various data and models. First, you can perform a crop growth simulation experiment using soil and water data and the results using the model and measure the predicted irrigation amount using the performed values. Containers then have converted these various models into APIs or saved as images. And the same saved images are saved for backup purposes because the problem may occur. Images saved for backup purposes are created as containers in Kubernetes and provide model API services. Then the data to be used for each model is stored in storage, and the object storage required by each model API is called and used. These data are called from the data storage provided by the Rural Development Administration and stored in the system's object storage. Using the image developed at Seoul National University, the backend system uses deployment, container image, service, and ingress to configure an environment that can provide external services. And when accessing from the outside, the system can be used by connecting to the following website through domain connection using Nginx. I will show you the current status of system development. We developed an interface for users and administrator, and Seoul National University developed a system and interface for the model API. I will explain the two interfaces. First, the part currently being shown is the interface part developed by Kisti. As shown in the figure, we developed the membership registration and login part to distinguish users. And we configured the interface that only administrator can access to manage the Kubernetes SAP and the monitoring system of the backend system. We developed it for the convenience of administrator. And users can easily change their password function. And then we also created a page called My Token. This page was developed to authenticate users using the Model API website. Model API users are required to use this token value to authenticate themselves when using the Model API. The token value is configured to generate a Python-based random string, and in order to receive this token value, it must be generated after signing up and receiving approval from the administrator. You can understand this by looking at the following demo. When you access the Model API website, you will see the following screen, and the current model is a model that shows the past incidence rate on a map. Therefore, the result is a map of the past incidence in the area. To use this service, you need an API key. API key, and you can copy it and this API key from the My Token page. So I show the web page. Maybe you copied the API key, and then you can get a job PID by entering the token value as follows, and then enter the API key and job PID and enter the model and the data for performing machine learning as input data. Maybe you can, if we look at the input data, it consists of a model and data. I show you this screen is model and data. Yeah, the task is currently running and it proceeds with machine learning until it is completed. Now you can show the running process and then when it is completed, the status changes to complete as follow. Yeah, now completed. And then if you enter the API key, job PID, and the parameter values required for machine learning, you will get the result. Yeah. The result appears as a zip file as follows, and open the zip file and then shows a map. Yeah, this website developed Seoul National University. Seoul National University is developing Chrome model APIs like this. Yeah. Okay, next page. Yeah. Currently, our system has some parts to develop, and we are preparing other tasks for this. And there are about 2 things to develop in the future. The first is to develop a system that provides an environment for model API, researchers to develop various Chrome models. Therefore, researchers will develop an environment where they can share object storage with each other, and the researchers will be provided with a container-based development environment so that they can develop individual model APIs. In addition, for such a system, we cannot ignore the security aspect. Therefore, we are strengthening security using ID, password, and token by introducing a system such as Gatekeeper. The second is the development of a system that automatically performs machine learning by linking models. So when we think about it, there are 3 types of machine learning models. The base model is a method of deriving results using one data and one model. And the pipelining model requires the result using another model and data for the results using one model and data. And the ensemble model is a model that derives the result by combining the result of 2 or more data and models into one result. As follows, the ensemble model requires an API that can derive one result using multiple models and data. And we want to develop a platform based on such API networking. In order to automatically perform ensemble models, an API networking system that can communicate between multiple containers is required. So, and then also we are currently preparing for our next project. Yeah. This concludes my presentation. Thank you for listening.
Thank you, Ki-hyun Kim. Anybody question in the field? Okay, one question.
Kim, actually, I wanted to ask you that you have implemented like Kubernetes in your multi-research platform. I wanted to know the thought process that why you choose Kubernetes and why didn't you go for like Podman, which are more feasible to the container orchestration platforms? And maybe you can discuss the difficulties in the implementation phases you were encountered there. Thank you.
Oh, I'm sorry.
Yes, I answered instead of him, and the Kubernetes is the power, the very strong power to the managing the distributed machines. So, and also the Kubernetes is very stable, the container, the provider. So our system is the based on this high bandwidth internet or NAN. So we need a very stable solution. The Kubernetes is the very, yes, more stable and very strong the management solutions. Yes, but there's limitation. Our solution is distributed. So the participant institute don't want to install this Kubernetes because that is my machine. So the third-party research or the operators is through the Kubernetes and managing as their system. At that time, we need the strong policy to using a distributed environment. Yeah. Thank you. Thank you for Kian again. And engineers, go ahead next. Asif Khan is ready.
Okay, thanks, Keon. Great presentation. Our final speaker in this session is Asif. Asif is from Perdana University in Malaysia, and he'll be discussing our HPC and bioinformatics activities. Kayun, could you stop screen sharing, please?
Okay.
Over to you, Asif. We don't seem to be getting your audio.
Okay, can you hear me?
Yes,
all good
well,
now.
It's good.
Okay. All right. So first of all, a correction. I'm no longer with Perdana University. I moved actually last year, February. So Jung Hoon, please update help update that information on your side. So I'm with actually University of Doha for Science and Technology in Qatar. So happy to be part of this session. And my talk is going to be a little different. It's maybe less technical, more biological, but rather bioinformatics. As an example of how the work that you all are doing can actually benefit and help people in the life sciences through bioinformatics to solve many important biological questions. And I'm just going to demonstrate some of the challenges that we are facing and how maybe, just to, maybe insight or trickle your mind on how you could, help us with some of these problems in the field. And it may even encourage you to explore or partner with someone in the field of bioinformatics to see how you can help. So all the technical stuff is good, but it needs to, of course, help move science forward. And this is what I've been doing, I think the last two meetings also, just giving a lot of biological examples to give people ideas of how the work that you guys are doing is impacting or can impact, benefit people in the field. So bioinformatics for the uninitiated, what is it? It's you can think of it as a data science for life science, and it's the bedrock of current and future biotechnology, is a key driver of life science. As I mentioned earlier, you can think of it as a data science for life sciences, and it's the lifeline, and we like to think of data science as the lifeline of Industrial Revolution 4.0. So data science is very important, therefore bioinformatics is very important for life science, and it enables a lot of the work that could not be done in the past because of big data. And the talk today is going to be largely on the big data in the field of bioinformatics. So bioinformatics underpins a lot of research. So you may have heard of genomics, or you have genomics, you have proteomics, you have metabolomics, all the omics out there. In fact, just recently I learned of a new omics, exosomics. Yeah, it's basically the external, external variables, or what do you call this, factors that are influencing your health. So that's another one. And there's another unknomics, things that we don't even know, proteins that we have not even identified. So that's basically a lot of area. The omics simply, signify that there are a lot of sub areas within biology that deserve attention and are impacted by big data. And bioinformatics is kind of revolutionizing the work that's going on in those areas. So, and a lot of this has happened because of big data that's coming out of modern technologies. You may have heard of next generation sequencing. And we have several iterations of that has happened, and it's getting much and much better, and being able to sequence larger fragments with higher accuracy. So this is so it's not stopping. It's only going to get better, and we'll have more piles of mountains of data, and that requires a lot of compute power to be able to mine that data and understand what's going on. And this data is, of course, very valuable. The kind of outcome that can come out of this would be medically, for example, novel diagnostics, novel therapeutics, new drugs, new vaccines. We just came out of COVID, so it's still fresh in our mind, and these things, these technologies are very important in order to expedite some of these work and to protect us from these challenges. Understanding metabolism, diabetes is a big problem. So there's a lot, that we can learn from all this data, understanding diseases, etc. There's no doubt that there's a lot of value that can come out of understanding biological data. Just to give you a sense of the complexity of the data, we are talking about one dimension, which is you are reading the sequence of your genome in one base, in one dimension. So you have the various amino acids, the various nucleotides, and then this can become 2-dimension, where you're looking at the interactions of genes or proteins. It can become 3-dimension. We are looking at the 3D structure of a protein, and it can even become 6-dimension. Basically the whole body and various dimensions, and then pieced together to have like a full grasp of what are all the information that's there for us to understand and make sure that we have captured all the possible angles. The other thing is, traditionally biology has been, or life sciences has been studied in the wet lab, through wet lab research, experimental work. Now almost every aspect of the wet lab, there is a computational corresponding component, right? So you have the experimental observations on this side. On the other side, you have the computational information that's come, basically the information that comes out of it, and then computational tools are facilitating the study of all that. So we have really come a long way. Experimental dry lab and wet lab have really married together and working together to move things forward. So biology is big science these days. We have sophisticated bioinstrumentation. Data is being churned out 24/7. BGI, for example, the last time I heard, was the largest genomics factory in the world, probably still is. And they're churning a lot of data. We have million genomes. A lot of big data projects are going on. So just to give you a sense of the big data, so I've chosen one resource, the EMBL, European Molecular Biology Lab, the European Bioinformatics Institute. This is the resource, the repository that they have, and they provide all kinds of data, literature, genes, genomes, proteins, chemical biology, drug discovery, molecular archives, molecular atlas, etc. And they have data not just from human, but actually all kinds of species. And this is just to give you a sense of the big data. So they have 82 million requests on their website every day, and they have from 24 million requests coming from 24 million IP addresses. And they have training that they provide for people to learn how to leverage on the data resource that they have, 30,000 trainings. And in terms of data size, 390 petabytes of raw storage. This is few years ago. The number obviously would have increased, but still, I think in the realm of petabytes. Just to give you a sense of the data scale, I'm sure you all are very familiar with this. So petabyte, 10 to the power of 15, but we are already, if you take all the biology in different resources, we are already hitting exabyte, That's 10 to the power of 18. Then I think very soon we're gonna potentially hit zettabyte and maybe down the line yottabytes. This is just to give you another perspective, like how fast it's growing. And sorry, what happened? Okay, how fast it's growing. So Twitter, for example, this was published a few years ago, 2015. So it's a little old, but just to give you some perspective, Twitter, it churns out 1 to 17 petabytes per year. Astronomy, 1,000. YouTube, 1,000 to 2,000. Genomics alone is churning out 2,000 to 40,000 petabytes per year. And if we were to take all health data put together, this is just going to be genomics is going to be, like, by 2025 the single largest producer of data. But if you take all other health aspects data coming out from there, I think there's no doubt that biology is gonna, or life sciences is basically gonna be the leading producer of data that needs to be analyzed and mined. So we are looking at 40 exabytes by 2025. And so the challenges are solving the data deluge in personal genomics. That's one of the contributor. Cancer genomics, million genome projects. How do we store the data? How do we analyze the data? How do we extract the information and knowledge from this large data? So again, compute challenges. And part of the problem is, in terms of mining data, biological data are fuzzy and complex, and they can be varying interpretations. There are problems in the raw data. They're inconsistent, can be inaccurate with human input, redundant, irrelevant, incomplete, incorrect. Right? Data cleaning is a big effort that's needed. It prevents propagation of errors into our databases, prevents depreciation of data. So data cleaning is very important, but it takes a lot of time, a lot of effort, curation. In fact, there are entities like EMBL, ABI hires people to do just that because of the problems with the data. So so it's not a straight, simple, simple effort whereby you just get the data, you put it, and you start analyzing. There's a lot of process that needs to be done in the middle before the analysis. The analysis maybe is the easier one, is the cleaning, and this is where automation and data stored in different places and integration of the data is a challenge. So there are disparities in data sources, data structures are different, data formats are different, the presentations are different, searching mechanisms, location, the download, non-interoperable tools, user friendliness to biologies is a challenge, privacy, security, the previous speaker mentioned about security, right? So with the current infrastructure, actually, so there's a quote here. If I could, I would routinely look at all sequence cancer genomes. With the current infrastructure, that's impossible, right? So we are looking forward to you guys to maybe participate in solving some of these challenges that we are facing in relation to infrastructure, in relation to the compute that's needed. Resources also are hard to maintain. Many of these works are done by PhD students, and they do not have a lot of access to these big scale resources. So software tools, they are very ad hoc in nature, and integration becomes a problem. Updating the databases become a problem. Therefore, we have this situation where databases or tools are of shorter lifespan, and they're hard to maintain, so they disappear, they become dinosaurs, obsolete. So some solutions, of course, integration. There are entities that are trying to look into this. Elixir is an example that's trying to look into this to see how we can integrate. There are efforts moving to the cloud, commercial and academic efforts to help with large-scale analysis. EBI is building a cloud-based infrastructure called Helix Nebula, the Science Cloud. Hosting mirror sites, data transfer between clouds can still be a challenge. Data highways are other solutions. Transfer of data, you have some commercial options, but again, it's for example, fast. This is from few years ago. Took 30 seconds to move 24 gigabyte file between China and UCSD. The main problem is not technical. I think some of these solutions are already out there, but it's rather economical. How do we make it accessible to as many people as possible? All right, so this is another aspect. And I'm just going to end by saying, we call to action for the APRP community, that is very good with supercompute, that's very good with big data, has a good understanding of big data transfers, supercompute, to reach out to us, the biologists who do not really grapple very well with all this technical stuff. How can we meet in the middle? And and your side could help our side solve some of these big problems. There's a saying here that 20th century was century of physics and the atom bomb, but the 21st century is century of biology and biotechnology. We have a lot of problems that can last the next 500 years. So please help us so we can solve many of these problems together. Thank you very much.
Thank you, Asif. Anybody question about that? Yes, I have a question.
Yes.
My question is, how much time do you spend managing the computing-related system? Because in terms of ratio, is given time to you or to your team, and how much time do you and to your system, to your team is managing the computing-related system?
So of course, I'm not going to claim I'm an expert, but we did set up HPC on our side, and because we were very novice, inexperienced, so it took us almost 1 year plus just to figure out and to set it up according to our needs. We had to a number of times wipe out everything, restart all over again because we realized we made a mistake. And then we had some problems with the scheduling system because we couldn't fully understand how it worked. We tried to meet with some experts and they guided us as much as possible. This is when I was in Turkey, small university, trying to figure out. The problem is, often we just do not know where to go and who has the time to help us out with all these details. And it's not like, you meet them one, they give you advice and that solves your problem. You really need somebody to be with you, to work along with you when you're setting it up. So we did spend a lot of time setting it up. And then occasionally, when we started analyzing, we realized it's not performing up to expectations. It's not very fast. It's very slow. It's taking too much time. So we end up waiting and realize we made a mistake. Then we have to start all over again. Basically, for someone who is unfamiliar, a little novice here, we end up wasting a lot of time. So it's been a frustrating experience. But we learned a lot, in the process, of course, and things are much better now. But just recently, we got a paper accepted, and there's a web server that we submitted. It was reviewed. Luckily, it worked nicely when it was being reviewed. And then after it came back for us to respond, the SSL certificate expired, and we just couldn't access. And little things like this, and this is probably not a problem for you guys because you probably have a dedicated team looking into all this. We do have IT people, but they're not familiar with biological research. So communication, gaps, challenges. But these are the frustrations we feel at the ground level. Researchers, biologists who are not familiar, we hear a lot, okay, supercompute, there's a lot going on, there's a lot of value, benefit, but I think it doesn't really trickle down. And when it does, we try to seek help. We do get help, but we often don't get, in an efficient way because everybody is busy and they're contributing voluntarily, so we can't really ask them to, work with us all the way and make sure that we get it right. So we do it whatever we can. So we do spend a lot of our time.
Yes.
We rather focus on the research and have the compute, be plug and play and does all what we need. But we are still, I feel, for small scale researchers like us, we are still quite far from that kind of a situation.
Okay.
I have a question, Jong-hoon.
Yes, go ahead.
Okay, yeah, I have a question to Asif. I just want to know, like in here, there are quite several NVIDIA sellers promote their GPU. So, but I just want to know because some of our bioinformatics here in our UPM, so they still not moving on from the application that run on CPU to GPU. So I just want to ask your opinion. Does the applications for bioinformatics is stable on GPU, if running on GPUs, or still preferred on CPU?
So I think there are some applications that can heavily benefit GPU. The problem is largely because of the lack of familiarity of the biologists on how to actually change the algorithm to be suitable for a GPU, because you can't just plug and play, right? There has to be a bit of a change there. And just thinking about that can sometimes be intimidating for them, especially many of the bioinformaticians that you have are basically who are trained as biologists and then started adopting bioinformatics. So they're more of users of bioinformatics rather than formally trained as bioinformatics. So, and even to be formally trained as bioinformatics, not many get training in terms of the computing aspects like algorithm design and how do you restructure from this architecture to that architecture. So I think what's really making it a kind of a turtle pace move is because of these issues. And I think, if somebody was really there saying, okay, let's work with your problem. Let's see if let's say, if I had a good understanding of all this and I could work with your team and really port them over, they'll be more than happy if there was a helping hand to guide them through and not just give one or two, have one or two meetings, advise them, and then just leave. I think what they need is really somebody to handhold them and walk them through. Then they'll be more than happy to port. I don't think biologists wanna, shy away from taking advantage of this technology to speed things up, to benefit their research. But if you were to expect them to do it on their own, I think it's going to take many years until they have within their own team somebody who fully understands. And usually as biologists, you don't want to deal with something that you don't have a full grasp of, because then you worry about it's black box, a magic box, and you put in garbage in, garbage out. They get very worried. Even a lot of the wet lab people, when you ask them to use bioinformatics tools, they're worrisome because I don't understand what's going on and how can I trust what comes out of this. So this was the concern, but I think more and more have warmed up and in fact started working together with bioinformaticians, but still a long way in many countries. Of course, like in the West, in the US, Europe, it's much more advanced. But I think Malaysia is making good progress. I was there for many years, but still, there's much to be done for this transition to take place.
Thank you.
Yeah, I agree. Thank you, Asif.
Thank you.
Okay, the Andrew, wrap up is session 2.
Okay, thank you everyone for joining our APRP session 2, and in particular, thank you for all the speakers. There were some absolutely fascinating presentations for both sessions. We invite you all to participate in the APRP with us going forward. We're always after new and young enthusiastic people, so please let us know if we can help you out in any way.
Thank you. Thank you.
Thank you, everyone.
Yeah.
Enjoy your lunch.
Yeah.
Bye.
Thank you for coming in the APRP session. Yes, at the finish. Thank you. Bye.
Thank
See you, everyone.
Bye, everyone.
Bye, Asila. Oh, the Asif is out? Okay.
Asif's gone.
Okay, see you.
See you, Jong-hoon.